Welcome to part 3 of the Chapter 6 Test Practice Solution Guide. So number 6. Oops. I'm going to give you the area formula for this one, so you don't need to memorize it. But what you do need to know is that S is the semi-perimeter. So it's going to be equal to half the sum of the lengths of the three sides. So the semi-perimeter is 8.65. So the area, 8.65 times 8.65 minus 6.3 times 8.65 minus 6.3 times 8.65 minus 4.7. And so we see the area is approximately 13.74 units squared. Number 7, we want to find the magnitude of the vector. And notice that they give us the endpoints of the vector. So the magnitude of the vector can simply be found by using the distance formula. So you can make that x1, y1, x2, y2 if you'd like. So we get 7 minus 9 squared plus 6 minus negative 8 squared. And we get 200 inside the radical, which approximately is equal to 2 radical 10. Okay, number 8, we want component form and the magnitude of vector u. So remember that the components are just basically the parts of the movement of the vector. So the first one's going to be the horizontal component. So my initial point is P and my terminal point is Q. So from negative 3 to 7, that's an increase of 10. And then for the vertical component, from negative 2 to negative 4 is a decrease of 2. So this would be the component form. So for the magnitude, we don't have to use the distance formula because we've kind of already figured out part of that. It's simply 10 squared plus negative 2 squared, which is radical 104. Which is 2 radical 26. Number 9, find the unit vector in the same direction as the vector u. So the unit vector is equal to the vector itself divided by the magnitude of the vector. Well, there's our vector. And so to find the magnitude, we'll simply square both 2 and 11, find that sum, and then simplify the radical. Gives us 125. Which is 5 radical 5. So the unit vector, we get 2i plus 11j over 5 radical 5. So I'll accept either of these answers. Yeah. So these would be the preferred. Number 10, find the component form of the vector that has the given magnitude and direction angle. So to find v, we'll take the magnitude times the cosine of the direction angle. That gives us the horizontal component. And 6 times the sine of 210 degrees will give you the vertical component. Now, since these are special angles, we can write these in exact form. The cosine of 210 degrees is negative radical 3 over 2. And the sine is negative 1/2. So we could write it as 6 divided by 2 is 3. Negative 3 radical 3, negative 3. If these aren't special angles, just feel free to type it in your calculator. Excuse me. For number 11, we need to find the component form of both these vectors. Add the vectors in component form together in order to find the magnitude and the direction. So for this problem, I'm going to call this one vector u and this one vector v. So the component form for u is going to be the magnitude, which is 50, times the cosine of the direction angle. Well, we see this 27 degrees here, but the direction angle for u isn't 27. It's going to be 90 minus 27, or 63 degrees. So that's the component form for vector u. Then for v, I'm looking for that angle right there, which is 180 degrees minus 41, or 139. So now we'll find u plus v. So first do the horizontal component. I get about 42.38. And for the vertical component, we get 64.23. Okay, you may have noticed that I typed something incorrectly. Congratulations. put sine in there instead of cosine. So here's the correct answer. So for the horizontal component, it's going to be about 0.058. And then for the vertical, we get about 64.23. So to find the magnitude, we'll go ahead and square both components, find the sum, and then take the square root of that. We get about 64.23. And then to find the angle, really we've got this very tall triangle right here. So we know this side, the opposite is 64.23. That's 0.058. So we'll take the arctangent of 64.23 over 0.058. And we get about 89.95 degrees.